All of you please listen. Rakshana, Said, Shivani, Deva, Ashley. The question is, how many words without meaning can be made from the letters of the word Monday, assuming that no letter is repeated if 4 letters are used at a time. If the question is simply arrangement, n factorial is okay. But here they specifically says that only 4 letters are to be used at a time. The first question says that only 4 letters are to be used at a time. The given letters are M, O, N, D, A, Y. These are the letters available. Monday, understood? Monday consists of these letters, right? I want to form a 4-letter word. I want to form a 4-letter word. It is just not about the arrangement. I mean, just by interchanging. The question is about forming a 4-letter word. These 5 letters are available now. So just box method is better. Understood? Draw 4 boxes because I want a 4-letter word. Let me record the class. So the question is, we have a word Monday. I want a 4-letter word using these letters, without any repetition. Understood? No letter is repeated, no repetition. So just draw a 4 boxes. These 4 boxes are to be filled. We have already done this type of question. The first box can be filled in 6 ways. 6 letters are available. I can use any of them. 6 ways. It is filled with some letter. Now I am going to the next box. Out of 6 letters, 1 letter is already in use. 1 is already lost. Now 5 letters are remaining. In 5 ways I can fill it. Filled with some letter. You can ask me doubt, but let me complete it first. Out of 6 letter, 2 letter is already in use. 6 minus 2, 4 letters are available. Filled. Now out of 6 letters, 3 letters already used. 3 letters are remaining. So filling all the boxes will be 6 into 5 into 4 into 3. Understood? 30 into 120, 360, right? 360 ways is the answer. The first question is done. So all of you please write down. If you don't understand any step, please ask. If you are okay, 100% clear and written, raise your hand. Say the Devasri understood. Shivani okay. Rakshana okay, understood. Ashley clear ayo? Ashley?
Yes, sir.
Okay. Complete ayadano Ashley? Okay, complete.
Yes.
Now we can go to next problem. 1 minute. We can go to the next problem then. First question is done. Then now let me discuss the second question. The second question, there are 2 methods available. The second question is 2 methods are available. All letters are used at a time. Monday. All the letters are used, can be used. So either you may draw the box, or the question is talking about just in how many ways I can form a different word with or without meaning by simply rearranging the letter. If I simply rearrange it, all the letters are used at a time, right? No repetition also, no repetition. So one method is, if you don't want to draw the box, fine. One method is all the letters are to be used. How many words can be formed using Monday? That is simply in how many ways the letters can be rearranged. So one method is there are 6 different letters. There are 6 different letters. The answer will be 6 factorial. Let me complete it. After that, we can ask me doubt. In how many ways, how many words can be formed by simply rearranging it? All the letters are used. So this is one method, or you may draw the box and do it. Okay, whichever method you can use. I will show you the both the methods. 720. Or another way is, I want a 6-letter word. All the letters to be used means I want a 6-letter word, right? I want a 6-letter word using the letters Monday, Monday. So 6-letter word to be formed without any repetition. This can be filled in 6 ways. Monday, 6 letters are available. Filled. We can go to next box. From 6 letter, one is already used 5 ways. Now you know the remaining steps. Okay, I don't want to discuss that. You are familiar with that. 1 should be decreased. 6, 5, 4, 3, 2. Is that correct? Yes, no problem, no mistake. Oh, sorry, one box I forgot to write. 6-letter word. Understood? 1. So in this way also you can find it. This is also 6 factorial, correct? So all of you please write down. If you are okay and written, raise your hand. Please remove your old raise hand. If you are okay and written, raise your hand. Said, have you understood, Said?
Yes, sir. Yes, sir.
Okay. If you have written, please raise your hand. Ashley clear ആയിട്ടുണ്ട് അല്ലേ? Okay, ഇത് complete ആണ്. Then we can go to the next problem. Okay. It's not a.
Sir, I had a doubt in the yesterday's homework question number 4.
Question number 4, you have a doubt? Oh, let me see. Fourth question. Okay. I will discuss. Actually, it is there in this exercise. Don't worry. I will discuss.
Okay, sir.
Now let me discuss the third question. Third question I am going to discuss. How many words with or without meaning can be formed, right? All the letters are to be used, but the first letter is a vowel. The condition is there. If the condition is there, definitely the box method is to be used. I have to form a 6-letter word. Monday, all the letters are to be used, meaning that I want a 6-letter word using the letters Monday. I want a 6-letter word. All the letters are to be used, but first letter is a vowel. First letter is vowel. What are the vowels in the letters Monday? Tell me, what are the vowels? Anybody? What are the vowels? O and A. See, A, E, I, O, U are the vowels. So in this letters O and A, there are 2 vowels. So the first, it says that the first one, all the letters to be used, but for the first letter is a vowel. So the first box must contain either O or A. First box must contain either O or A, because the first one is a vowel. So in 2 ways I can fill it. Either O or A. Okay, give a tick mark. Now I am going to next box. All the letters are to be used, meaning that we are not repeating the letter. I am using all the 6 letters. Now there are total 6 letters are there. 1 letter is already in use. Understood? Same technique. 1 letter is already in use in this box. So from 6 letters, 1 is already lost. 1 is already lost. 5 letters are remaining. You can fill in 5 ways. Tick mark. From 6 letters, 2 letters already used. 6 minus 2, 4 ways. Tick mark. Then 6 minus 3, 3 ways. Tick mark. And 6 minus 4, 2 letters are remaining. 6 minus 5, only 1 letter is remaining. Filling all the boxes will be the product. Understood? So what is the product then? 240, correct? 240 ways is the answer. So I hope you have understood. All of you please write down. If you are okay, return, raise your hand. Shivani Deva, remove your old raise hand. Say the understood. Shivani, okay. Ashlyn, clear. Rakshana, you understood? Rakshana?
Yes, sir.
You did not send me the homework, Rakshana. Devasri, understood?
I sent it for it.
Devasri,
Yes, sir.
completed. Can I go to next problem?
Yes, sir.
Okay. Ashlyn, which question you have a doubt? Question number?
4.
Fourth question you have a doubt.
Yes, sir.
You did not get the answer. Find the number of 4-digit number that can be formed with no digit repeated. How many of them will be even? Actually, it consists of 2 questions. Then let me discuss it. Shivani ചെയ്തതാണോ ഈ question, fourth one? Shivani, okay, Ashlyn, I will do one thing. I will share Shivani's answer. Ashlyn, you just check the solution. Still, if you have any doubt, you please message me. Okay.
Okay, sir.
Ninth one I discussed. Now let me explain another topic, another formula. So in the previous class we studied that n different letters can be arranged in how many ways? How many ways? N factorial ways. Okay. N different letters, understood? A word consists of n different letters given, then I can form n factorial different words. But the problem is, if there is any repetition, what we can do? Let me discuss with the help of an example. Oh, here there is no example. I will give you another example. Let me give a heading. Let me write a heading. Arrangements. Heading. Arrangements or arrangements if some objects are identical. Some objects are identical. For example, I have a word Mississippi. I have a word Mississippi. The question is, how many different words can be formed by interchanging the letters? That is the question. Or in how many ways the letters can be arranged. So my question is, how many different words with or without meaning can be formed using Mississippi? So here the answer will be less than n factorial, because in this case, if you make some interchange does not change the word. Some interchange does not change the word. For example, this S go to this position and this S go to this position. You please read it. The same word you will get. So we will not consider double counting. Double counting is not allowed. So some interchanging does not have any effect. Some interchanging does not have any effect. So we will not consider that interchanging. Then there are plenty of such cases. For example, I go to this position, Thus I go to this position, still you will be getting same word. So some interchange does not have any effect. So such interchanging will not be considered. But on the other hand, if you have a different word, if all the letters are different, like equation, whichever interchanging you do, you will get a different word. Whichever way you do the interchanging, you will definitely get a new word. But here some interchange is not considered, because you will be getting same word. I want a different words. I want a list of different words. So the formula, there is no direct formula, but I will explain how to write the value. Okay. So the question is, how many different words can be formed, or number of arrangements, number of words, okay, by interchanging the letters of Mississippi will be. The method is, all of you please listen. First of all, you please count the number of letters. First of all, you just count the number of letters. 1, 2, 3, including repetition. Count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters. So first of all, write n factorial. It is very difficult to write the formula. I will explain this question. I will give you 2 examples. So the first step is n factorial to be written. N stands for the number of objects, including repetition. So n factorial to be written, then divided by. Then you just consider the repeated letters. Which letter is repeated in this word? I is repeated, right? The M is not repeated. Only consider the repeated letter. I is repeated how many times? 1, 2, 3, 4. I repeated 4 times. So you have to write 4 factorial. Into. Any other letter repeated? S is repeated 4 times. Only consider the repeated letters in the denominator side. S is repeated 4 times. So 4 factorial. Into. Any other repetition? P is repeated twice. So into, every time multiply. Okay, 2 factorial. Any other multiplication, repetition? No. So in the denominator side, you have to write the, repetition factorial to be multiplied. That's all. Okay. It is very difficult to write the formula for this type of question. So this is the way. So how to write the number of letters if some objects are identical? Numerator will be n factorial divided by, in the denominator side, you just consider only the repeated letter. I is repeated 4 times, so 4 factorial written into. S is repeated 4 times, so 4 factorial is written into. P is repeated twice, so 2 factorial is written in this way. I don't want to calculate its value. If the numerator is very, very large, you need not simplify. Okay. If you stop here, you will get the mark. Because 11 factorial is much larger. Or you may find it. Okay. Anyway, method is clear. All of it clear? The arrangements, if some objects are identical, is that okay? Is that okay?
Yes, sir.
Yes, sir.
Okay. Then another word. Can you suggest any other word which contains a lot of repetition? Can you? One minute. Just a minute. Just a minute. Consider another word, assistance. Question is, how many words can be formed by rearranging the letters? So number of words with or without meaning. Same way, first of all count the number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 letters are there. So n factorial is written. The denominator side, which letters repeated? A is repeated twice. Can you see? A is repeated 2 times. It's 2 factorial into any other letter repeated. S is repeated 3 times. So 3 factorial. Any other repetition? I no. T no. N no. C no. Okay. Only A is repeated. S is repeated. So this is the answer. So is that okay? All of you please write down. If you are okay, 100% clear, raise your hand. Number of words by arranging the letters. Okay. Shivani okay. Devasri clear. Rakshana Said okay. Ashlyn clear. Okay. The next is the last one is tough question. The last one is a tough question. Eleventh one. One minute. Question number 11. In how many ways can the letters of the word permutations be arranged if the words start with the P and end with the S? So permutations to be arranged, but there is a condition that the words must start with the P and end with the S. All of you please listen. The starting letter is P, it is fixed. Fixed, cannot change. Starting with the P. Then E, R, M. The positions of E, R, M can be changed. Okay. M, U, T, sorry. Permutations, right? The last letter S is fixed. So when we do the interchanging, never do the interchanging like this. The first position always occupied by P. Last position always, tell me.
There is one more T.
One more?
T.
Permutation. Okay. Yes, very good. Okay, correct. Permutations. Okay. So I will tell you the best way. So we need to think about only these letters. Understood? These letters can be interchanged themselves like this. But P and S, never touch P and S. Never touch P and S. The other letters can be interchanged like that, but never touch P and S. Understood like that. So we will be dealing with only these words ERMUTATION. P and S is never touched. So just think about the number of arrangements of ERMUTATIONS. Understood? So how many letters are there in this middle portion? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 letters. There are 10 letters. P and S are not considered. 10 letters can be interchanged or arranged in 10 factorial ways divided by. Any other repetition? E no, R is not, M no. T is repeated twice, correct? T is repeated twice, so 2 factorial to be written in the denominator. Any other repetition? No, so no need to write any other number, okay? So 10 factorial by 2 factorial is the answer of the first question. If the numerator is much larger, you need not simplify, okay? Denominator you may write 2. Because 10 factorial is 10 into 9 into 8 into 7 into. If you want to do the multiplication, okay, you can do it. Otherwise, you can stop here. 10 factorial by 2 is the answer of the first question. Everyone is okay? Said, Shivani, Deva, Ashlyn. Clear?
Yes, sir.
Okay, please raise your hand. If you are okay, please raise your hand. Ashlyn. Everyone is clear. Okay, then we can go to the next problem. Second question. We can go to the second question. Sorry, is it different one? 1 minute. Oh, sorry. Copy paste. Not correct. 1 minute. The second question is permutations to be arranged. All the vowels are adjacent. I discussed this type of question in the previous class. Permutations, what are the vowels? In the word permutations, what are the vowel? E is a vowel. E is a vowel. U is a vowel. A is a vowel. I, O. A, I, O, U. All the vowels are there in the word permutations. E, U, A, I, O. Is that correct? Okay. The vowels are adjacent. If the questions specifically say that some group of letters are adjacent, you have to consider it as a single bundle, single group. Okay? Cannot be separated. It's a bundle, thing like that. And other letters are P, R, M, T, T, NS. All the vowels should be adjacent. Other letters can be anywhere, no problem. Okay. So the question is clear to you. Is that okay? Everyone, is that okay? Clear? Let me leave a small space. To explain to you, let me leave a small space. P, R, M, T, T, NS, right? So the vowels are adjacent. Consider vowel as a single object. Okay. Now consider this as a single object. This is the first object. Second, let me number like this. Otherwise, you will have confusion. Fourth object, fifth object, sixth object, seventh object, and eighth object. If certain letters are always adjacent, consider it as a single object. Consider it as a bundle. So that whichever way you do the interchanging, this bundle will go together to another place. Understood? This bundle considered as a single object. So when you do any kind of interchanging, this bundle will go as a single object to another place. So that is the way. Okay. So there are how many letters, how many objects are there? 8 objects are there. 8 objects are there. 8 objects can be arranged in n factorial ways by. If there is any repetition, the divide by is required. 8 objects are there in total, 8 factorial ways divided by. Any repetition? Can you see any repetition? Repetition is there. T is repeated 2 times. Not completed. Now parallelly you can do this type of interchanging like this. Okay, this kind of interchanging is okay. Parallelly you can do another activity. The internal arrangement of the vowel is possible. Still the vowels are adjacent. Understood? E, A, I, O, U, A, E, I, O, U, the order of the vowel is not important. So the internal arrangement of the vowel can be done parallelly. So if any other event can be done parallelly, you have to multiply it. E, A, I, O, U, 5 letters are different, 5 factorial ways. The vowels can be arranged in their positions. Okay. This is the answer. You can find its value. Let me complete it. After that you can ask me doubt. If the number is larger, you need not do the calculation. Okay. 8 factorial into 5 factorial by 2. Okay. Or you may do the multiplication. 8 into 7 into 6 into. Okay. So all of you please write down. If you are okay, Clear? Return, raise your hand. Rakshana understood. Devasri, Said, Shivani, Ashley. Everyone okay? No doubt? Devasri, have you understood? Clear?
Yes, sir.
Okay. Third question is tough. Okay, third question is a tough question. There are always four letters between P and S. It is really a tough question. Okay, there are always four letters between P and S. So all of you please listen. How many letters are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Understood? 12 letters are there. The question says that only 4 letters are allowed between P and S. Only 4 letters are allowed. Here there are different cases. Here there are different cases. One is the first position occupied by P, and 1, 2, 3, 4 S occupy this position. How many letters are there between P and S now? Now if the arrangement is done like this, right now there are 4 letters between P and S. Understood? So this is case 1. Okay, only 4 letters allowed between P and S. So permutations, in the word permutations, look here, let me write here, permutations. Permutations. 12 letters are there, only 4 letters are allowed between P and S. P and S are already occupied the seats. Delete P from the list. Delete S from the list. How many letters are remaining? 10 letters are remaining now. 10 letters are remaining. Is it correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters are remaining. So you may write it. Okay, okay, 10 letters are remaining. For the time being, let me write it. E, R, M, U, T, A, T, T, I, O. Is there any mistake? E, R, M, U, T, A, T, I. Okay, okay. T, I, O, N. P and S are fixed. The other letters can be interchanged in any way. For example, E go to the position of A, but A go to the position of E. R go to M position, M go to this place. U go to I position, I go to U positions. Except P and S. Except P and S, other letters can be arranged in their seats. Except P and S, there are 10 letters, right? This is case 1, okay? Except P and S, there are 10 letters. 10 letters are arranged in 10 factorial ways. But 2 repetition, T is repeated twice. So except P and S, other letters can be arranged in 10 factorial by 2 factorial. But remember, it can be SP also. I mean, the order is not important. Instead of PS, it can be SP also. So PS can be arranged in 2 factorial or 2 ways. 2 ways. Understood? Instead of PS, you can write SP. The condition is only this much. 4 letters are allowed between P and S. So instead of PS, it can be SP also. So 2 times 2 to be multiplied. Let me complete it. After that, you can ask me doubt. Okay. So for this setup, the number of arrangements will be 10 factorial by 2 factorial into 2. Why I am writing into 2? Because instead of PS, it can be SP. Now, all of you please listen. Is there any other possibility? There is another possibility. Only 4 letters are allowed, right? So another possibility is the P is shifted to this place, S is shifted to this place. Still there are 4 letters between P and S. P shifted to this place, S shifted to this place, hence P and S are fixed there. In that case also there are 4 letters. Understood? P in the second position, S in this position, and their position is fixed. So there are how many such cases shifting? P is shifted to this place, automatically S is shifted to this place. Or P is shifted to this place, automatically S is shifted to this place. So first case, second case. P can be shifted to this place, S can be automatically shifted to this place. P is shifted to U's position, S is shifted to this position. P is shifted to S position, S shifted to this position. P is shifted to T's position, S is shifted to Nth position. If you need, I will write all the cases, but it will take time. So it is not necessary that P occupy the first position. It is not necessary. P can be in the second position. If P is in the second position, S must be the position occupied by T. If P shifted to this place, S shifted to this place. In how many ways such shifting is done? 1, 2, 3, 4, 5, 6. When P reaches here, S reaches the last position. After that, no more shifting possible. So if P shift one position, S is automatically shifted. 4 letters are allowed. How many such cases are there? 1, 2, 3, 4, 5, 6. So there are 6 cases are there. So into 6 will be there. Understood? For a given setup of P and S, there are this number of vases. In this way, there are 6 possibilities are there. Shifting, okay? You please write down. If you don't understand, you can ask me doubt. Okay, it is a tough question. All of you please write down. Ask me your doubt. Ask me your doubt. Shivani understood. Devasri, Shivani, Rakshana, Ashlyn clear. Said okay. So everyone is clear. Okay. So calculation I don't want to discuss. A few more steps you may write. 10 factorial into 2 factorial is 2, right? 2 factorial is 2. 10 factorial into 6. Or you can find 10 factorial. 10 into 9 into 8 into, okay? So please write on. All of you have finished. Is that okay? Question is clear to you? You understood?
Yes, sir.
Okay. So we can go to the next one. We can go to next. Then NPR is there. This, can you see that? NPR. I will discuss NPR later. Because before this kind of question NPR, I must discuss NCR. I must discuss NCR. Then it will be much easier for me to discuss NPR. That is why. Definitely I will discuss, don't worry. So let me go to the next topic, combination. After discussing all the problem related to combinations, I will come back to this NPR. Only 2 questions are there in textbook. NPR is not so important, but combination is the most important thing. Okay, let me start combination. So all of you please listen. Next topic is combination. Next topic is combination. Another name is selection. Another name is selection. For example, let me begin with one example. Let me start with an example. Let me write a question. Then only you can understand. Okay. Find the number of ways of selecting two students from three students. Can you find it? Find the number of ways of selecting two I start with a simple question. Okay, find the number of the combination. The meaning is selection. Find the number of ways of selecting two students from two students. Three students. Can you tell me the number of such selection? Anybody? Can you tell me? Okay, and I will discuss that. I will discuss. Suppose the students are total. How many students are there? Total how many students are? 3 students are there. Let me name them A, B, C. I want to select 2 students. The possible selections are, if I select A, B, it is a possible selection. A, B. Once I write A, B, then B, A is not required. We are not considering order. Understood? I am not considering order. 2 students to be selected. One possible selection is A and B selected. Another possible selection is B, C. B and C selected. B, C order is not considered. Okay. Then A and C selected. Any other selection possible? No. So 3 students are there. I want to select 2 students. In how many ways I can do such selections? In 3 ways I can do the selection. 3 selections are there. All of it clear? This one is okay? Selection understood? Please respond.
Yes, sir.
Yes, sir.
Okay. But here we can list them. But the problem is, if there are 50 students and I want to select 10 students, it is extremely difficult to list like this. So we need a formula. Understood? We need a formula. This selection is very important in the chapter probability. We will learn the chapter probability later. Probability is there in both 11th standard and 12th standard. Without combination, the problem very difficult. I mean, most of the questions require the selection in the chapter probability. Okay. So the problem is, if there are many students, then listing is very difficult. So let me generalize this concept. Number of ways of selecting are objects. Or let me write are people. Okay. That is much easier to understand. Okay. Are people from n people. N people means n different objects. Okay. If I write like this, you can understand. Okay. Number of ways of selecting R people from n people is denoted by. There is a symbol representing this. Denoted by NCR. NCR meaning that total n people are there. I want only R people. So the upper number represents total number of people. This lower number means how many people to be selected. That is R. C stands for selection. Understood? I mean combination. So combination of R from N. We have a formula. The proof is not required for us. N factorial by R factorial into N minus R factorial. Proof is not needed. Here n should be greater than or equal to R, because total number of people definitely greater than the number of people to be selected, right? That is why NCR equal to n factorial by R factorial into n minus R factorial. So let me use this formula and let me verify we get the same answer. Okay. So in the given question we get the answer 3 selections using that formula, because I want 2 selections out of 3 people. 3C2. Understood? Because total how many students? 3 students. How many I want? 2 students. So mathematically the number of such selection is denoted by 3C2. Let me use this formula and I will verify I am getting the same answer. NCR form, right? N is 3 here. N is 3. So n factorial by r factorial into n minus r factorial. N factorial by r factorial into n minus r factorial. 3 factorial, 3 into 2 into 1, 6. 2 factorial is 2 into 1. 1 factorial is 1. I get same answer. So if the number of people is much larger, the formula to be used, the listing will be very difficult. So have you understood NCR? The meaning of NCR is clear? Okay. So all of you please write down. If you are okay and written, raise your hand. Devasri, Shivani, okay. Say the Ashlin. Everyone is clear. Okay. So NCR, the meaning of NCR is clear. Okay. In mathematics, in numerical questions, there is another way of finding NCR. For example, let me start with an example. For example, we have a number 10C3. In two ways we can find it. One is using formula n factorial. If you use the formula, there is no problem, but you have to write some 3 or 4 extra steps. I will tell two methods for finding NCR. One is formula n factorial by r factorial into n minus r factorial. So 10 factorial divided by 3 factorial into 7 factorial. 10 factorial is what? 10 into 9 into 8 into what is the remaining number? 10 factorial, 10 into 9 into 8 into what is remaining? 7 into 6 into etc. Correct? 7 into 6 into etc. is 7 factorial. Denominator is 3 factorial. 3 into 2 into 1 into 7 factorial. 7 factorial cancels. And after that you can cancel again. 3, 9, understood. 9 by 3, 3, 10 by 2, 5, like that. So what answer you will get? 5 into 3, 15. 15 to 8. 120. This is a formula. I found NCR using formula. You may reduce steps. First and second step you can avoid. You will get marked, don't worry. The formula is used, but you can, if you avoid the first and second step, how can we find 10C3 after removing 2 steps? I will tell you. In numerical questions, NCR can be found without writing first 2 steps. How? 10C3 to be found. Start with the 10. Start with the 10. Then subtract 1 again and again. You start with n, so start with 10. Subtract 1 again and again. 10 minus 1, 9. 9 minus 1, 8. Stop there. This is 3. Only 3 product is allowed. Whatever be the number in the lower side, only that much of number is allowed. So start with n, subtract 1 again and again. Where should I stop? The lower number is 3, so only 3 products are allowed. Denominator is simply factorial of this number, only that much. Okay, denominator is simply the factorial of that one, which is 3 into 2 into 1. The same thing, okay. In that method, the formula method, the same value I got, understood. So this is much convenient, especially in the numerical question. But there are other questions like NCR related, formula related question. But in numerical, this method is much convenient. Another example I will give you. Say for example 7c4, sorry, not 7c4, 8c4. Either you can use the fact formula or use this technique. You start with the n, start with 8, subtract 1 again and again. 7, 6, 5, where shall I stop? This number is 4, so only 4 product is allowed. Denominator, just factorial of this. You will get the answer, understood? 70 you will get. So you please write this one, okay? If you are okay, return, raise your hand. If you don't understand anything, please ask. Say the everyone, Ashlyn, okay, clear. Everyone is okay. So NCR formula we studied. Most of the questions based on NCR in this chapter, okay? One minute. Let me discuss one question, okay? I am discussing the last exercise. Let me discuss third question, application oriented problem. Let me begin with the application oriented question, okay? Question is, how many chords can be drawn through 21 points on a circle? What do you mean by chord? Do you know what do you mean by chord? We have a circle and there are 21 points on the circle. The first point, second point, I don't want to show 21 point here, okay? There are how many points on the circle? 21 points, understood? I don't want to show all the 21 points here. There are 21 points on the circle. The question is, how many chords can be formed? In order to get a chord, I want to select 2 points. For example, if I select this one and this one, this will be the corresponding chord. But if I select another possibility, the first one and this one is selected, I get another chord. If I select this one and this one, I get another possibility. So the number of chord means in how many ways I can select 2 points. If I select 2 points, we get a corresponding chord. So in how many different ways I can select 2 points, that number of chords will be there. Total 21 points available. I want to select 2 points for a chord. So in how many ways I can select 2 points? 21 C2 ways I can select 2 points. This is the number of chords. Let me in simplest way we can evaluate starting with the n, 21. Subtract 1, you will get 20. The lower number is 2, so only 2 product is allowed. Denominator is factorial of this 2, 2 into 1. 210 chords I can draw. All of you please write down. If you don't understand anything, please ask. Devasri, Shivani, if you don't understand anything, please ask. If you are okay, okay. Devasri, Shivani, everyone is clear? Rakshana? Say the understood. Okay,
Yes, sir.
okay. Try this one as homework, okay? How many triangles? If you are not getting, don't worry, I will discuss in the next class. Let me add one question here. How many triangles can be drawn? through 21 points. Let me change the number, okay? Through 15 points on a circle. You try it. Let it be a homework question for you, okay? If you have written the question, then you may leave the meeting. Okay.